Welcome back to another how-to video. Today we're going to be talking about contactors. Specifically, we're going to walk through how to wire up a typical control circuit for a three-phase contactor that you would wire up, say a three-phase 480 motor, three-phase 240 motor. It can even be wired up to single-phase motors as well, but we're just going to stick with three-phase, keep it a little bit simpler. I try to keep these videos as short as possible so they're not too terribly long. I know I need to slow down my speech a little bit. It's a comment that I've received several times now, so I'll try to slow it down a little bit, but I try to move a little bit quicker through these videos so that people can, maybe if they're learning on the job, they can pick it up and kind of move through it quickly. So I try not to spend too much time, and you can always pause and go back and re-go over it. So I do try to cover every bit of the topic. So we're going to start off with contactor. This is just a Fuji contactor, and it's got a 24 volt DC coil on it. If you haven't seen my relay video, I recommend watching that first. The relay video walks through troubleshooting and how it's wired in a circuit. And let's go ahead and switch the camera over here so that we can just go ahead and jump right on into it. So what I've got here is, I got my little drawing in the background. What I've got here is my contactor, right? And I got my contactor, right? That pulls in. You see on the side there, you can see it actually moving. See it actually pulls in. And what this does is when the coil is powered, okay, you see how you've got 3 connections here, 3 connections down here, and you have 2 more on the top. This is my coil right here. Just like in a relay, what that does is that creates the magnetic force that pulls this down. And it allows this contact to make with this contact, this one with this one, and this one with this one, all in a row. So you have 3 separate legs making contact with 3 separate legs down here. This right here is just an auxiliary block. We'll show and see why we use this. That mounts right on the front of that. This is a set of overloads right here. It's a set of adjustable overloads where you can actually adjust the current trip point. And it has a set of contacts, 2 sets of contacts on it as well, okay? As you can imagine right here, I've got my 3 legs. And then if you look down below, I've got 3 legs here. These over here to the side are overload contacts, okay? So typically, this is just going to be wired into the bottom of that, nice and neat like there. Your 3 legs of power are going to be coming into the top. Now let's pull that up on the picture real fast for you and see how this wires in the actual circuit. So what you've got here is you've got 2 separate circuits here, okay? Separate but together. Think of them as 2 separate pieces. Over here I've got what's called my control voltage. Now I picked 24 volt DC because it's typically what I'm working with nowadays in controls, but it could be 120 volt AC. It's just that the coil, okay, the coil, or go ahead and bring back over to me real fast. The coil right there, where your A1 and A2, much like a relay, A1 and A2, it actually is written on there, A1 and A2, is the coil voltage, okay? Now, my handwriting, after I put this over, is a little bit blurred, but that's A1, that's A2, this is my coil, okay? 24, I'm going through a stop button, here's a start button, this says M, and this says M. It could be M1, M1, M50, MC, MC, MZ, MZ. It wouldn't really matter. Long enough as this symbol here is the same as this symbol here. What this is this is latching. This is how you build a typical start-stop motor contact circuit. Okay? So this is controls. This is automation, just no PLC. Most of your automation you're dealing with nowadays, you have a PLC in play. In this case, there's no PLC in play. But this is where our programming logic actually comes from when we're doing PLC programming. Is it comes from the same sort of logic, the same sort of base logic. So let's walk through how this works real fast, okay? So my power comes through here. It goes through my stop button. This is normally closed, okay? So it's making contact. Now, I can't go any further right here because my start is open, and I can't go anywhere over here Because my contact is open. So I can't go anywhere until I press my start button. What happens is when I press my start button, right? I got myself a handy dandy little button right here. Okay. See it on the side there, the black button shows up. Springs return. It doesn't hold in on its own. I have to press on it, right? When I press in on that start button, and it's only momentary, that's what we call momentary push button, it's going to pass power through the start button and to the coil of the contactor. See, and then what happens from there is once that contactor is pulled in, just like a relay, okay, I'm closing this auxiliary contact. Okay, this is just a normally open auxiliary contact that is physically mounted, and I'll show that to you in a second, to that. So now that I take my finger off of the start button, right? I take it off the start button, power can no longer pass through here, but because this is closed and this is closed, now it'll actually hold itself on, okay? And the way that we stop it, now that we've got power flowing through it continuously, is the normally closed stop button here. We press it and it breaks all power going that way. And then once we break it, right, it could be a momentary stop button. We break it, this drops out, we take our finger off of it, it recloses because it's a normally closed, and power now can no longer go any further to power this coil because this has now been opened again, okay? So you see that right there. This is just a motor latching circuit, all right? And I'm going to show you the pieces and parts to this too over here. So this would be auxiliary contacts, okay? There's my motor contactor. I would just go ahead and I would mount this joker right there on that like that, okay? And what ends up happening is when we pull this in, this actually gets pulled in, okay? If you can hear that. Get that close to the mic there for you. Okay, so this actually gets pulled in. Everything, you can see that on the side. See that right there? See, that's getting pulled in when I press down on the front of that because it's all mechanically interlocked. So what ends up happening is these are just sets of contacts and they're labeled like normally open, normally closed. This has got 2 normally closed and 2 normally opens on them right there. The camera can't quite see that great, but matter of fact, there we go. Maybe you can see that a little bit better right there. And then what that does is that gives us, jump back over to our picture, that gives us our contact here for latching, okay? So that right there would be what actually will hold that in, okay? So if I want to break this, I have to hit my stop button, right? Well, what if I want to put other things that can stop it? Like an e-stop relay, or what about the overload? So let's get back to the overload. We haven't quite got to the motor yet because that part's actually a lot easier. A little bit easier to explain too. Let's talk about the overload, okay? So if we want to, we can actually go through the normally closed set of contacts here on my overload. And what happens is if the motor overloads, it's going to open up that physical connection inside of it. And what will happen is then it'll stop it. And how we would wire that in is on either side of the stop, because it needs to be wired in series, we would simply wire this in and then this would come back out. And this would need to, the wire that's coming out of it would need to be prior to the start switch, okay? So anything, you could put any of your stops in here, just normally closed stops in here that would open up, right, before the start button. They all go in series. And then what we call in programming an OR, right here, these would be ands. If we stack them all, we could put 4 different stop buttons. They just need to be, say the motor was, really far down the line, but you wanted 4 different stops in. Well, you just run one wire and you just daisy chain them into the back. And how we do that is with some normally closed contacts. So this particular brand makes it kind of easy. All right. So in our button, we can actually change those from normally open, which is my green ones here, the red normally closed. They make it nice and easy. Some of these are black or gray plastic, and it doesn't really matter. They'll be labeled on there somewhere. But this particular brand makes the green normally open and the red normally closed. Makes it very easy to identify. So anytime I'd want to put any of these stops, all I'm going to be doing is I would just be wiring them in series. Pretend like that one's a red one. I would be going wire here, wire coming out here, into here, into there, to my start button, right? It just all has to be before that start button. And then on the start button, what it is, just like in our picture there, is the wire coming from my stop side, right, is coming in. And what I'm going to be doing is, let's say if I want to tie in the motor contactor here, we'll just make it nice and close for you. We'd be coming out of there, and it would be paralleled, okay? So I'd have a wire going here and here, and this wire over here would be coming back to the same point as this other side, as you can see in the picture there, or if we go ahead and zoom in right there, okay? So this is my control side of the circuit, and that's mostly what we're covering in this. But let's briefly go over this part right here, okay? So this is three-phase 480. We're going to have three-phase 480. And how we're wiring that, I hit the wrong button. How we're wiring that is all we're doing is we're coming in and we're just putting phase, phase, phase right there. And then this would be attached, I have my overload attached to the bottom, and coming out the bottom would be my 3 legs of power that go out to my motor, okay? Simple enough, right? And the reason that we have it, these are my contacts inside my contactor, and these are just my overloads represented in my drawing right there, and this is representing my motor. So that's my 3-phase motor, and I'm just wiring that up. Just a little trick: if the motor's turning the wrong way, all you have to do is switch any one of the 3 wires. You could switch it on the top of the contactor, you can switch it on the bottom of the contactor. It doesn't matter. Just any one with another one of the 3. Doesn't matter which 2. I can pick A and B. I can pick B and C. I can pick A and C. It doesn't matter. Just swap any 2 around and your rotation will change direction. So that's the basic walkthrough of how that works. Now let's talk about troubleshooting this. Like I said, I'll try to keep this short. I'll try not to speak too fast, but let's talk about troubleshooting a contactor, okay? So if I'm troubleshooting a circuit like this, the first things I'm going to do is I'm going to make sure that nothing else is wrong in my circuit, okay? So I want to make sure that I'm getting power up to my start button, okay? So what I'm going to do is I'm going to take my multimeter, and because we're on 24 volt DC, I'm going to turn that to my voltage DC, right? We're doing this on a system that has power on it, okay? I got myself a nice little fisheye view here for you guys. And what I'm going to be doing is I'm going to be checking up to my start button. So if I have a start button like this, right? Like that right there. I'll flip it over so you guys can see the back of it, right? So what I'm going to be doing is I'm going to be checking and seeing from here, and then my other lead is going to go on my reference, which in this case is 0 volts. And I know that my contactor's A2 is tied to 0 volts. So if I can't find any other close by, I might just go ahead and go to that one, okay? That's going to be wired into 0 volts, and I'm going to test that, and I'm going to say, okay, do I have 24 volts there? If I have 24 volts there, it's fine on that side of it. I might press in on the button, actually physically press in on the button. You know, sometimes you feel like you gotta have 3 hands, but I'll use meter leads that have some clips on them, or I'll just shove them in on top of a thing, and I'll actually press on the back as well, okay? I'll press on the button, okay, and make sure that I'm passing power to the other side. Once I've verified that I've got 24 volts going all the way through like that, then I say, okay, is my contactor pulling in, right? Is my contactor actually pulling in? Actually, if I heard it pulling in, I probably wouldn't worry too much about my 24 volts, but I would make sure that I have enough, because if it was dropping a lot, say I was getting like 18, 19, even 20 or less, I might say, okay, I've actually got a bad contact going in my start button or possibly my stop button, which I have seen several times, especially in very dusty environments that make any kind of like plastic like product or anything like that that insulates well. It makes its way into the contacts and for some reason seems to find its way there, and I'll start seeing voltage drops, and then my stop button or my start button has a problem with it. So I'm looking for my power going through. I don't see it. So if I don't see it, then I'm checking, each one back, okay? And you can check that also very easily by checking across it, leaving it on voltage, and then you don't necessarily have to check against 0 volts. You can actually check across it, and because what your meter's doing is actually checking for a difference in voltage. And I'll do a video. There'll be a separate video on multimeter and what it really means and stuff. Checking for a difference in voltage. So if I actually go right here and I take a look across my stop right here, and I have more than a couple of volts, I need to look at replacing that, or maybe cleaning it out, blowing it out, maybe hitting it several times with my finger, knocking some of the dust and dirt out until I get a better voltage reading, which again I've seen several times. Same goes for my start button, same as goes for there, same goes for my auxiliary contact on that right there. Okay, now I don't want to be cycling power to my motor on and off rapidly like that. That's very, very bad for a motor. That's very bad for everything involved, your contactor and everything involved. So if I don't have I'll turn off my 3-phase power, and I might, to get them running for the time being, I might, cycle that, recheck my voltage, do like that, just to try to knock out some of the junk or whatever, if I don't have something that I can replace it with really quickly. So, which in the cases, a lot of our cases. So now I'm going to focus on the contactor itself. So if I've got power going in, right, I've got 24 volts here. So I'm checking here. I'm just checking just like my relay in my other video. Checking A1 to A2, okay? I don't have 24 volts here or something very close to it. If I don't have 24 volts here, then I'm checking back here. If I do have 24 volts here and nothing's happening, this is not pulling in, okay? My coil's gone bad, right? My coil's gone bad. So this thing needs to be replaced. My contactor has to come out, unless you're dealing with a very old style contactor where the relay is actually replaceable. I love those old NEMA size 2 starters that would clunk in and out. We can actually replace everything on them. You can replace the contacts, you can replace the coils. And things still see them in use today. So they were built to last. But if that's not the case, then you're going to need to replace that right there. You make sure you get the proper sized overloads when you do it. If you don't have the exact brand match, which after several years, it's in any of these cases, it's usually pretty difficult to find the exact brand match. Make sure you're getting the right overload sizing though, if that's the case. So let's say for argument's sake for this video, it is getting pulled in, but my motor's not coming on. Well, we got another piece to worry about here. We also have our overload as well, okay? So in the case of this right here, what I want to do is I want to test, and overloads do go bad. They actually go bad decently frequently, actually. So if it pulls in and my motor's not coming on, the easiest way to do is just to come down to the bottom of my overload and actually check phase to phase down here. Now what I'm going to want to do when I do that, because I'm dealing with 3-phase, is I'm going to want to change my meter, move my hand out of your way, I'm going to change my meter to AC voltage, okay? I'm just going to move this out of the way, and we're just going to make it easier to see for a moment. So what I'm going to be doing here is I'm just checking phase to phase here, and I'm looking for my 480 and I'm seeing what it looks like, okay? And I'm taking a look here, and what I'm looking to see is I'm looking to see a very, very similar value on all of my legs. I don't want them off of each other. I know 480 system by more than 10 volts, okay? I don't want to see anything more than 10 volts. It may work and it may run with that difference, but once I start seeing that, I'm starting to worry about my contactor, and I'm worrying about my overloads and how well it's making contact. Maybe retightening down the screws might help. Retightening down my conductors here might help. You know, going through and doing that. If there's a lot of dust and dirt in there, again, maybe, you know, pulling out my conductors, you know, blowing it out, and then going ahead and putting them back in. That might help to fix some of that. When you start to see voltage drop, it could just be that it's dirty. But in this case, what I'm going to do, well, I'm going to try to just get this to wedge in there for me, so I don't have to do it. So here's the other way of doing this, okay? What we're going to look, like I said before, your multimeter reads a difference. That's why you got two probes, okay? Like a tape measure, you're measuring a difference. Well, again, I'll talk about that in another video. So here, what I'm going to be doing, I want to measure here to here, okay, from top to bottom, right? And we'll move this over in the frame a little bit better. I'm going to measure from here to here, and I want to see what my voltage difference is across this, okay? So I'm wanting to see very small numbers, and I'm wanting to see similar numbers across all of them, okay? And what I'm doing here is what I'm really doing is I'm measuring the internal resistance in this across the whole circuit, through my contacts, through my screws, everything that's touching down here. It's coming through my overload, and it's making all the way to the exit end right there. And what I'm doing right here is I'm taking a look, because when these things start to go bad, they don't all go bad consistently. It's not like all three of them go bad. They start arcing in there and burning up, and they start having problems. So when I'm doing this right here, I'm taking a look, and I'm seeing, and I'm looking for a voltage difference. And again, I don't want to see more than about 10 volt difference. So when I have it on AC like this and I measure here like this, I don't want to see more than 10 volts, okay? And what you'll do, when you're doing this, you're measuring voltage, and even though you're in the voltage, what you're actually doing is you're measuring its internal resistance in a live circuit, because you're not measuring resistance. When you go to resistance in a live circuit and you do this, that's a bad thing. You don't want to do that, okay? That's not how you measure resistance. When you measure resistance on your meter, you're doing that without power on, which you can do. You can press in on these and actually measure resistance, but it's a lot easier to do it with the power on, okay? So if I've got good voltage down here, right? I've got all my voltage, my contactor's actually pulling in when it's being told to pull in. You know, we've already gone through that. I'm getting three-phase 480, very consistent, A to B, A to C, and B to C, like that. See how I'm doing it, right? I'm checking all the combinations. That's all I'm doing, and I'm making sure that those are very even. If all of that looks good, all of this looks good to me before going out to the motor, then I probably have a motor problem if the motor's not coming on. Okay, it's most likely a motor problem. If it's tripping immediately, what I would recommend doing is pulling your motor leads off and then letting your motor starter pull in, tell it to actually come on, you know, let it turn on. If possible, check all your stuff down here just to eliminate it as a potential possibility, because I've seen all kinds of arcing and shorting and funny variations of problems in these things. Just verify everything's good. Make sure it resets, make sure everything's fine, and then move on to troubleshooting your motor. But this video, we're just concentrating on a motor contactor, how it's wired in without a PLC, and its logic, your typical latching motor starting circuit right there, all together. So that right there is one of many different how-to videos that we'll be putting out. We have a classroom that is upstairs that's built just for hands-on training, where we do boot camps, and you get to actually wire these things up, put them together, troubleshoot them live, You get to look at PLC code and HMI code and see how it all talks together, and this stuff begins to make a whole lot more sense. Hopefully we can continue to put more videos out. Check us out, www.improvemaintenance.com. The link will be in the description. Thank you very much for your time, and tune in again, please. Oh, like and subscribe. It helps the algorithm. Nobody wants to listen to a blue collar guy very much, so I appreciate your time. Bye-bye.